All right, so we're on journal entry, guys, part C. So you guys did problem 1 for homework. I did A and B last time. Let's pick up with C. So it says a score of at least 20 is needed to pass the test. So we know we need the score must be greater than or equal to 20 in order to pass. Suppose a student knows the correct answer for 18 questions. So 18 I know. And I answer correctly for those 18. I answer correctly for those 18. And I choose randomly from the 5. So 7 I guess. And I randomly pick. So what is the probability I'll pass the test? Okay, so I need a score of 20. So I'm going to go ahead and put 20 right in here. So I need 20. So that's the minimum I can get is 20. I could get higher, of course. That'll be fine. But the minimum is a 20. And that is to be equal to, if we go up, it kind of gave us the general formula. So that's equal to 1 times the number of correct answers. And if you remember from part B, we said the number of correct answers is equal to, well, 18. I know I'm going to get those right. Right? I know I'm going to get the 18 right. Plus, if you remember from last time, we called it y. And y was equal to the number I guess and get right. So y is the number I guess and get right. So I know my 18, I'm going to get those. And then my y is the number I guess and get right. Then I'm going to subtract. Let's close this parentheses. I'm going to subtract 0.25 times 7 minus y. Does anybody remember why we did the 7 minus y from last class? We talked about why we put 7 minus y here, Jennifer?
Because 7 is the total of the ones you guessed, and y is the number of the ones you got corrected. So when you subtract it, you get the ones you got wrong.
Yeah. If there are 7 that I'm guessing on, and I get y of them right, 7 minus y would be the amount I get wrong. And then I don't really need to worry about the 0 because I'm not going to guess on it. I'm not going to leave any blank. So here we have this. So I know that 20 must at a minimum be equal to 1 times 18 is 18. 1 times y is y. Minus 0.25 times 7 is 1.75? 1.75? And negative 0.25 times negative y is plus, so we keep the minus out here, minus 0.25y. We just left the minus out here. We'll deal with that in a little bit. All right, so now we'll just continue simplifying. We have 20 equals 18 plus y minus 1.75, and the negative and negative is plus 0.25y. Plus 0.25y. Okay. So now I could say, well, 20 equals 18 minus 1.75 is 16.25. And this is 1y plus 0.25y is plus 1.25y. Right. Alex?
Why'd you turn the minus sign into an addition sign?
Because negative and negative becomes plus. You got to distribute the negative 1.
So shouldn't you just... Oh, okay.
Does that work?
Yep.
Okay. So let's see. What can we do now? Well, I want to solve for y, so I'm going to minus 16.25 on both sides. I'm going to minus this over here. I'm trying to solve for y. So I've got 20 minus 16.25 divided by 1.25 must equal y. Okay. We subtracted. But this is just a number. 20 minus 16.25 divided by 1.25 is just a number. Right? And if you do this on your calculator, 20 minus 16.25 is 3.75 divided by 1.25 must equal y. It's a number. 3.75 divided by 1.25 is just 3. So that means 3 has to equal y. And if you really think about it, we actually said that the score could be 20 or more. Right? So really this is a greater than or equal to here. Because the score could be a 21, a 22, or however high it could go. So really this should say y, right, needs to be, what, greater than 3? Is that right?
Yes.
We want y to be greater than 3? Because we want the score to be above 20. So we want y to be greater than 3. It could be 3, so greater than or equal to 3. So we want the probability that y is greater than or equal to 3. Is there confusion about why this is greater than, Takurtra? Is that what you're No. Okay. So we want the probability that y is greater than or equal to 3. So we want the probability that y is greater than or equal to 3. So how am I going to do that? How am I going to find the probability that y is greater than or equal to 3? Now this is where we come back to the binomial. This is where we come back to binomial. Tamar? Three? Oh, P. Sorry. Yep. Okay. Let's see if we can take the next step. Shamar? 1 minus p equals 3. So we have made some progress. We still need to make some more progress. Remember, I'm trying to find the probability that y is bigger than 3. Remember, the only possible values for y are 7, 6, 5, 4, 3, 2, 1, and 0. Because there are 7 questions I'm guessing on. Eddie Paul, what do you think? Jennifer?
Then you have to add, so it's 1 minus the probability of 3 plus the probability of 0 plus the probability of 1, 2, and 2, right?
Okay, so you're saying you want me to now add?
Like, because you're going to subtract 1 minus all of the probabilities that are below 3, right?
Right. So how am I going to write that? I agree with you.
So don't you just add all of them and then subtract those from 1?
Right. So I think a nice way to write this is the following. So a nice way to write this is this. The probability that y is greater than or equal to 3 is equal to, so what can y not be? It can't be 2, it can't be 1, and it can't be 0. So let's just do 1 minus the probability y equals 2 minus the probability y equals 1 minus the probability y equals 0. Because we know y has to be 3 or more, so it can't be 2, y can't be 1, and y can't be 0. And now each of these I can figure out using my formula, Alex.
You don't. Why aren't those addition signs though, instead of subtraction signs?
So okay, so another way to think about it is this is the same as if it is easier to think about this, that's fine. These are the same thing. So here we say we're going to add all of them up and then subtract it. Here I've just distributed the negative through. It's the same thing. Either way, whatever is easier for you to think about is fine. And now everybody should be able to calculate these. So let me model the first one and then you guys can follow the rest. So the probability that y equals 2, we know this is a binomial distribution. So probability that y equals 2 says, well, we do, what are the maximum 7 trials, and k is 2. And then we multiply that by the probability of success. If there's 5 answer choices and I'm guessing, what's the probability of success? 5 answer choices I'm guessing randomly. 1 out of 5, so 0.2, 20%. So 0.2 raised to which power?
Okay.
To the k power. In this case, k is 2 times 1 minus 0.2 raised to the 7 minus 2 power. This right here is this probability. Then we need to do the same thing for 1 and for 0. So let's go ahead and do that now. Are there questions on how to do this with the calculator or even the process? If you're good, go ahead and finish it off. So you want to find the probability of 2, the probability of 1, and the probability of 0. So let me take some questions for those who might be a little bit unsure.
Hold on, I'm gonna see how. No, how do you do that?
That's a so you have a calculator? Yeah. So you go to math, or sorry, go to menu, you go to probability, and you go to combination, and you put 7, 2.
And then continue on with the
And then continue on. Just close that parentheses on the combination. We cannot stop this, Alex. No?